In this video, we're going to be looking at exponential expressions. But before we begin with solving these problems, I need us to quickly revise the 7 most important laws of exponents. Okay, the first one, let me get a pen. The first one is this, is that if I have x to the power n multiplied by x to the power m, I'm going to basically, you see here we have the same exponent. We have x here. I mean, you have the same base. You have the x here, you have the x there. So you keep 1x, and then because you are multiplying, you have to add the exponents. So the rule is when you multiply the same bases, you have to add the exponents. Okay. And then the opposite of this rule is this one, which is the second one. I have x to the power n over x to the power of m. In this case, I still keep the same base because I have the same base, which is x, and then I have to minus the exponents now because I'm dividing. So when you divide, you keep the same base and then you minus the exponents. Okay. Then now let's do rule number 3. So the third law is saying if I have x to the power of n over x to the power of m, and then I have another exponent outside, let's call that exponent a. The rule says this, it says the outside exponent must multiply with the inside exponents, all inside exponents. It must multiply with all inside exponents. So we're going to have x to the power n times a, which is an, right? All over x to the power a times m, which is am. Do you see it? And then that is how you remove the brackets in exponential expressions. You multiply all the exponents inside the brackets with the outside exponent. And you can see that this now applies to that rule there. Do you see it? You can now minus the exponents if you want to. Perfect. And then number 4 is the same thing, but with multiply. I have x to the n dot x to the m with to the power of a. I'm going to multiply that and that to a. So n times a, it's an. So I'm going to have x to the power an dot x to the power am, right? And then from here, you can see that I can apply that rule because I have the same basis. I can decide to say x to the power an plus am, which is adding the same basis. I mean, you are adding the exponents if you have the same basis. You see, also here on 3, I could have just said, okay, I have x, I have x. I could have said 1x, and then here I have an, here I have minus am, right? Perfect. And then rule number 5 says anything, no matter how many letters I have here, I can say to the power 2, to the power 3, to the power 1. If it's to the power 0 outside, the answer is 1. So it says any base raised to the power of 0, the answer will be 1. That is what the rule 5 say, right? And ladies and gents, please note you do not need to know these rules in order. There's no specific order you need to list them. The most important thing is to know all of them. The order does not matter. Okay. Perfect. And then the other rule is this. If I have x to the power negative n, I can write it as this. Just check it. You always want to leave your exponents as positive. Now you have a negative exponent there. And you can see that the x is now a what? It's a numerator. To change the sign on the exponent, you have to make now x the denominator. So the x will come at the bottom. Then the sign here will switch. And then here you're just left with 1. Do you see it? So you always leave your answers as positive exponents. And then the last one, last but least, you have n square root of a. let's say to the power m, right? This rule says this. It says you can always convert the rule to the root, to this. Ne? Inside you have a to the power m, and then you put a bracket. This n here can be written as 1 over n. Do you get it? It's always 1 over whatever the root is. If you have a square root, you are going to have 1 over 2. If it's a cube root, you have 1 over 3, and so on. And then from there, you can see that you can apply this rule or this one. You can multiply this, and that is going to be a to the power m over n, right? And those are the 7 most laws of exponents that we're going to apply throughout our study of exponents. Please, ladies and gents, learn them and know them off by heart. Okay, perfect. So now I'm going to erase this portion. I'm going to erase all this portion. Oh, sorry about that. Let's bring that back. Okay, let's see. I think it's easier to just apply the eraser. Ne? Okay, here. So let's just erase that quickly. Okay, perfect. So now, ladies and gents, now that we know the rules, we can apply them here. Ne? On number 1, I see that, okay, let me use a different color. I feel like using green. No, not green. Let's use black. Okay. So the first most important thing, you need to remove the brackets, right? Sharp. So remember, the rule of the brackets is this. The inside exponent must multiply with the outside exponent. The inside exponent must multiply with the outside exponent. So you're going to have 5, which was already there. And then m, you can now see that 2t times p is going to be 2tp. You see it? 2tp. Perfect. And then you have multiply by 2. And then here you can see that is going to be m to the power 3p times t is 3pt, or 3, let me just say 3tp. I'm trying to keep the same order as there, right? And then from there, ladies and gents, you need to know this. Numbers work with numbers and letters work with letters. So I'm going to firstly always deal with numbers. I have a 5, I have a 2. So 5 times 2 is what? Is 10. So I'm going to have 10 for the numbers. Then I'm done with the numbers. And then there's a law that says if I have the same base, I keep one base and then I have to add the exponents, right? So I'm going to have 2tp plus 3tp, because those are my exponents, and then I can simplify this to 10m, and then this can give you 5tp as an exponent. And that is finito. Our exponent is in positive, so we do not have to worry. Right. Awesome. Ladies and gents, if you understood this question, I want you to pause the video and try number 2 and check the solution. That's how you learn maths. You don't learn maths by just watching. You learn maths by doing. So I advise you to always pause my videos and try the next questions that I'm doing to see if you can be with, to see your understanding basically. Okay, sharp. So that's it. Let's do this one. So I have 8, I have k cubed, I have x squared. So here inside the bracket, remember I have x to the power 1, I have k to the power 1. Remember, they don't show you when the exponent is 1. They expect you to know, right? And then applying that rule of the outside multiplies the inside, you can see that you're going to have 2 times 1 here, which is 2, which is going to give us x to the power 2. Then you have 1 times 2, which is still 2. And then it's going to give you k to the power of 2, right? And then we can see from here that 8 is just the only number that is there. It doesn't have a mate, so you can just keep it there, right? But k has a mate. You see it? So at the top, I have k to the power 3. Okay, let me do this. So we have k here, we have k here. So we're going to keep 1k and we're going to subtract the exponents in this case because because we're dividing here, so we need to subtract the exponents. So we have k to the power 3 minus 2. You see? So in simple terms, anything from the bottom switches the sign. K was positive 2 because it's coming to the top, it's becoming negative 2. If it was negative when it's at the bottom, when it comes to the top, it's going to be positive. So, ladies and gents, you need to know that anything that comes from the bottom is going to switch signs. And then we can also see that this x has a mate there. So we can replace them as 1x. And then this 2 is at the top, stays the same. The 2 at the bottom will minus because it was a plus there. Then now let's simplify this. We have 8. 3 minus 2 is 1. So we're going to have k to the power of 1. And then we're going to have x to the power of 0, right? Which gives us 8k. Remember, to the power of 1, I don't have to show, I expect you to know. And then times 1. Remember, we said on one of our rules that anything to the power 0 is 1. And then you can see that the 0 in this case just affects the x. So the final answer is 8a. Okay. Perfect. Let's go to number 3. Ladies and gentlemen. Okay. So on number 3, we are going to have this. We are going to have 2 to the power 2 dot 3 to the power 1 dot 7 to the power 4, right? And then I'm sure we agree that this is 7 to the power 1, that is 2 to the power 1. And then I'm sure we remember that the outside exponent must multiply with the inside exponent. So we're going to have 7 to the power 4 dot 2 to the power 4, right? Which is going to give us this. You see, you have a 2 here. This 2 goes with that one. You are going to represent them with this 2. So it's going to be 2 to the power 2. The 4 will change the sign to minus 4. Then you have that 3 to the power 1, which does not have a mate. You leave it like that way. Then you have 7 to the power 4 there, which has a mate here. This 4 will change the sign to be minus 4 because it's coming from the bottom. Then you have 2 to the negative 2 dot 3 to the power 1 dot 7 to the power 0, right? Perfect. And then 2 to the power negative 2 must go at the bottom to become 2 to the power 2. Remember, we said we need our exponent as positive. So if it's negative and it's on the numerator, it now becomes the denominator. And then here 3 to the power 1 will just be 3. 7 to the power 0 will be 1. This simplifies to 3 times 1 is 3 over 4 because 2 squared is 4. And that's it with number 3, ladies and gentlemen. Now let's look at number 4. Let's look at number 4. So on 4, we have 3 in bracket, 3 to the power b, and then you have a, right? So here, remember I said the first thing, you need to remove the brackets. So you have 3, b times a is going to be ab. So you're going to have dot 3 to the power ab, right? Then here you have 3 to the power 1. Now you have the same base is 3 to the power 1 plus ab. Remember, same base, we need to add the exponents. Okay, ladies and gents, right? And I'm going to show you another example where we're not going to apply these rules now when you add or subtract. And in the coming videos, I'm going to be doing examples of this nature, but now I'm just introducing it so that you get a feel of it. It's very easy as well. Né? It's very easy and simple. So let's go here. Let's go here. It should be somewhere here. Sharp. So in this one, ladies and gents, the difference is you still have the same basis, but now you have a minus somewhere. So always, if you have a minus or a plus, you are going to approach your sum very differently. Né? You are going to approach this sum differently. So this is how we're going to approach it. The first thing, you need to split all these exponents. So you're going to have 3 to the power m minus 3 to the power m dot 3 to the power 1. You see, we split this to 3 to the power m and then 3 to the power 1. You always have to split them. Immediately you see a plus or a minus in exponential expressions, you need to split. Then you have 4 dot 3 to the power m minus 3 to the power n. Right. Perfect. Now, ladies and gents, I'm going to do this. Let's highlight this. You can see that this part here, you're only interested with the part with the letter or the variable. So this part has the variable. You highlight all of them. Sharp. After highlighting them, we are now going to do this. Right. You open a bracket. You see here, you have a minus. So it means you're going to have a minus there. And then you do the same at the bottom. You open a bracket. You have a minus here. So you're going to put a minus. Right. Now we are going to do this, ladies and gents. You take this out as a common factor. You write it here. 3 to the power m. All right. So if I take out 3 to the power m here, it cancels out. So I'm left with 1 there. So 1 comes in. If I take 3 to the power m out, it cancels out. So I'm left with just 3 to the power 1, which is 3. Then we do the same at the bottom. You take 3 to the power m out. You're not interested in any other thing, ladies and gents. You are just interested in the 3 with the letter or the number with the letter. You always take it out as a common factor. Or sometimes we'll factorize using a different method, but that will be a more advanced question. Basic level 1, 2, 3, it's always just taking out a common factor. Okay, so in this case, I take this out, I'm left with 4 this side. Here, I take this out, I'm left with 1 then. Do you see it? Perfect. And then we can all see, ladies and gents, that this will cancel with that, right? Perfect. And then here, okay, let me come back here and explain something. Someone might be tempted to say, okay, this will cancel with that. That is incorrect. Why? Because how many terms do you have on top? You have 1, 2. How many terms here? 1, 2. The moment you have more than 1 term on either of the sides, you cannot cancel, ladies and gents. You cannot cancel. You only cancel if you have 1 term at the top and 1 term at the bottom. That's when you can cancel. Just like in this case here, if you check here, 3 times this bracket is just one thing. It's attached by a multiplication sign there. So it becomes just a single term. Also at the bottom is just a single term. So you can cancel. Okay. Sharp. So now I'm left with 1 minus 3, which is minus 2. And then at the bottom, I'm left with 4 minus 1, which is 3. And this is my final answer, ladies and gentlemen. Okay, thank you very much for your time. If you found this video helpful, please don't forget to hit the subscription button and to share with family and friends. Remember, sharing is caring. Aluta continua. Tango.